clean water. Every day we need more of it, worldwide. The space and energy consumption for water purification is therefore constantly increasing. Is there a way out of this? Through revolutionary new processes? One of these technologies is granular activated sludge. But how can it become a real revolution for wastewater treatment? In sequencing batch reactor plants, all phases of biological wastewater treatment take place in one tank. Additional settling tanks for pre- and post-clarification are not required. Aerobic granular sludge makes this process even more efficient, energy-saving, and reduces the space required. The much more compact and dense sludge flocks settle up to 5 times faster than conventional activated sludge. In smaller plants, this technology is already in use and proven in practice. But where a new revolutionary technology is most needed, in large plants, there has not been a simple and reliable technical adaptation available until now.
We asked ourselves, how can these process steps be carried out simultaneously in one single basin, without walls and complicated internal piping, without large equalizing tanks in the inlet to the wastewater treatment plant, and for large basins, sometimes more than 100 meters long and very deep?
A modular concept would be ideal. A concept that can be adapted to any plant size. A design with a higher level of process stability for hydraulic peaks and load fluctuations than any other system.
It became clear to us very quickly that we already had exactly the right components and the expertise to implement this concept in-house. Our solution is the Invent Granular Sludge Reactor, in short, iGSR. The iGSR shows what is possible with specifically applied fluid mechanics, optimized reactor and process design, and innovative products.
We made the activated sludge process even more effective by using a mixture of conventional and granular activated sludge. This way we combine the advantages of both processes.
In this large-scale Invent Granular Sludge Reactor, the wastewater is fed at the inlet of the basin. The mixers not only ensure homogeneous and sediment-free mixing, but also supply oxygen at the same time. The reactor design allows for a continuous volume flow towards the end of the basin, where the cleaned water is discharged by a decanting system and excess sludge is removed. The secret of the iGSR, however, lies deeper.
In the flow simulation, you can see that the basin of the iGSR consists of several continuous stirred tank reactors, because the hyperbolide mixers create a virtual wall between these cascaded zones. How the water moves successively from zone to zone can be seen in the single process phases of the IC3 process design.
In the IC3 process, the inflow of wastewater is completely mixed with the activated sludge. Due to the anaerobic conditions in the first zone, partial degradation of organic compounds already takes place at this stage. The mixers then operate in aeration mode. The concentration of oxygen increases with each zone, reducing the chemical oxygen demand of the wastewater by nearly 100%. In the next step, the mixers run at increased speed for a short time. This strong mixing degasses the sludge flocks and avoids foam formation at the water surface. Then, the mixers in the first zones operate more slowly. This leads to a high food-to-microorganism ratio, while the rear mixers are switched off to minimize denitrification. The virtual wall effect also allows different degrees of settling and biokinetic conditions to run simultaneously within one tank. The sludge, which is now completely settled, continues to be mixed with a continuously incoming wastewater at the front, while the mixers at the rear remain switched off so that the cleaned water can be decanted optimally and excess sludge can be removed. Reactor modules like this can be easily combined, and thus a plant can be expanded and adapted to site-specific requirements, simple and fast.
The mixture of granular and conventional activated sludge acts as a flock filter for impurities and the smallest particles during settling. It also makes the process more robust. The result is biologically purified, crystal clear water.
The iGSR system is already in operation in various plants worldwide, with more facilities currently under construction. All this is only possible using our fluid mechanically optimized products and our unique in-vent reactor design, which we have developed and continuously improved over the last 25 years.
The iGSR is the first system that fully exploits the potential of granular activated sludge and makes it accessible to large plants. Reduced process times, higher purification performance with a reduced footprint, low energy consumption, and reduced life cycle costs, at the same time delivering high reliability.
This is how you turn your existing plant or your new facility into a truly revolutionary plant.